Hello and welcome to a new episode of the Cegeka podcast. I'm Mihai Popa. At Cegeka podcast, we have short discussions with people connected to the IT world on technology topics, and today our guest is Andrei Petreanu, who is a tech lead with Cegeka's artificial intelligence team and lecturer at the Polytechnic University of Bucharest on artificial intelligence and machine learning topics. We will be talking about his latest project, a voice based virtual assistant in the not so widely spread Romanian language, which can save a great deal on call center costs, but can also evolve to much more. So, Andy, welcome.
Hello and thank you. Thank you for having me.
Right, so could you let us in on the nature of this project? Just what is it about?
So we've been trying to keep up with the latest trends in machine learning, and we've been doing a really good job at that in computer vision, I'd say. We've got a lot of results and lots of projects in computer vision, but last year, well, 2018, 2019 to be more exact, has been an amazing year for natural language processing, natural language understanding and technologies and architectures developed in this kind of spectrum of technology of machine learning. So we've stumbled upon an initial client who wanted to do things better than they already had with basically classic chatbots or chatbot system that existed previously. And we went into it basically head on. We had no expectations. We didn't know what we're gonna find. And what we did found is an enormous amount of new technology emerging on this side of natural language understanding, with lots of headlines and lots of improvement by companies such as Google or OpenAI, or even Nvidia and Facebook. So basically, we are addressing a need in the market for cheaper customer service, cheaper customer care, and we wanna do it as naturally and as flowing as possible, with an assistant that can basically interact with you in a conversation and guide you on your way to what you're looking for. So the nature of the project is basically this: natural language understanding, with transformer models, transformer neural networks.
Okay, all right. And going to this, where did you? I mean, I don't think there is necessarily a pre-existing library on the Romanian language that you were able to use, is there?
So no, there isn't, and there's lots of languages that don't have language models developed in them with the transformer architecture. What the people at Google, because they're the main drive of this innovation in this sector, have done is that they basically they produced a new architecture, a new research, and they only trained models on English and Chinese, those being the most important markets. So for the rest of the world, we kind of had to catch up and try to do it ourselves using like the hints and the insights that they gave us. We For every other language out there, you have to do it yourself. You have to know what you're doing and implement this transformer model in your own language. We had a quite a hard time finding the data set. It needs to have a very comprehensive, very large data set of text to train on, and we used Romanian Wikipedia and other couple of sources. But the Romanian Wikipedia is much smaller than the English Wikipedia, for example. So
So right,
we had
you
to.
need you need to train your assistant before it can actually understand and produce generate
Yes.
speech.
Obviously, so there's also there's a couple of layers of abstraction here. So first you need to train a language model. What that means is basically you're going to have a neural network that understands the context of your language and the context of words in a sentence, for example. And then you're going to fine tune that network to understand a specific vertical of a customer, or basically a client. Like you want to do telecom, you want to do banking, you want to do travel. You're going to have to fine tune on those particular verticals with their own content. And when you want to transition from text understanding and text responses to speech, you were mentioning something about vocal. That's an entirely different neural network called a tachotron. We're using a tachotron 2 right now, and it's a neural network that basically inputs text and outputs vocal.
Okay, I'm gonna go back just a little bit to the Wikipedia training that you've used. How did you even go about it? I mean, did you just parse every single page in Wikipedia and try to make sense of it, or
Yeah, so we had a we found online some type of a crawler specifically designed for Wikipedia that would strip away all the unnecessary metadata and figures and all that's not text. And we used this well, this basically a free resource that you can use to do this. So we used this to extract only the text of Wikipedia, and then at training time for the language model, we just feed it random sentences from the data set that we have. We also used subtitles for movies and some type of reviews, I think, and some Reddit subreddits pages. So we used a number of other resources too. We found a couple of novels, like book corpus stuff. We used that too. Um, it got pretty big at a point, yeah.
right? As far as I know, there are several training methods that you can employ, um, such as I don't know, supervised training or self training, so forth.
Yes.
Which ones did you employ?
Basically used all of them. So for the first task, which is training a language model to understand the context of your utterance, let's say, we used a self-supervised method, which basically consists of randomly masking words in a sentence, and then we taught the neural network to basically predict what the randomly masked words were. And this is a self-supervised learning method. It's basically self-trained because there is no ground truth, there's no annotation process. You just take random sentences out of the dataset corpus, and then you randomly mask out 50% of the words, 15% of the words, let's say, and ask the network to produce the missing
Sort
words.
of fill in the
Uh,
blanks.
yeah, basically fill in the blanks. Like if you'd say, I want to go to, or let's say, the theory of relativity was invented by, and then the network has to produce something that works there, and it's gonna say Einstein. And that's pretty amazing. The fact that w- at the end of this training process, the network actually contains a type of a squishy model of the knowledge of the world. So if, for example, I'd say anything related to Ceausescu in the Romanian context, the network will probably complete a sentence, say that Ceausescu was a president or that Ceausescu is now dead, which are all true. And it's pretty impressive because it's not just contextual information, it's also knowledgeable information.
Indeed, indeed. So right now, the virtual assistant that you have worked on is generic. How do you go about implementing it for, let's say, a specific industry? If I have, I don't know, a shoe store
Yeah.
or something like that, how do you go about actually making it relevant for the specific vertical and context that a particular business
Yes.
is in?
So basically, at this point, after you self-supervised train this type of a model, you're going to have a language model that understands the context of your language and the squishy information of your context. But you can't really do much of anything with this other than, complete fill in the blanks for sentences. And that's not really useful for industries or businesses. But what you can do is you can try to fine tune that network to produce user intents or entities, dynamic entities inside of sentences, or you can do sentiment analysis and all other types of downstream tasks. And this will work fantastically good if the pre-trained model starts out with a language model trained in your language. So basically, when a customer or when a new client comes to us to implement some type of natural language understanding technology for them, we we ask them for data. Obviously, we need conversational data that they use with their customers. We need emails, we need messages, all anonymized so that they're GDPR compliant. And then we annotate this data. So this is no longer a self-supervised training process. It's a supervised now. The human supervises the process. So we annotate this data with the intents of each utterance and the entities of each utterance. And then we ask the network to learn about intents and entities and sentiment analysis. So that's a whole different process that we go through. It's like the second step is educating the language model to become proficient for your own industry or vertical.
Right, makes sense. And let's say that I'm in a completely new industry. I'm in a service industry of a particular vertical. How many messages would you need to parse or analyze or annotate in order to be able to train the assistant in this particular vertical?
Well, it's really amazing what technology has come up to. The fact that you already have a pre-trained language model that basically understands your language and context means that in the second step, you don't have to train it for so long or with so many, data points. So, for example, we had a demo for an insurance company the other week, and they basically gave us like a pretty easy flow of doing some policies over some insurances, and we had about 100 lines of conversation, and we augmented those 100 lines of conversation in different ways. Ended up with about, I don't know, 500, I think it was 500 lines of conversation, and then we trained on those 500 lines, and it was pretty good already. So obviously more data results in better generalization, better accuracy, better performance, but we did it with 100 lines from the client.
That's amazing because I know I remember from the computer vision projects that we've had that we needed thousands upon thousands of images to make sense of.
Yeah, but this only happens because the pre-training, the initial pre-training of the language model, that probably takes up to something like a billion lines of conversation. So,
Okay,
so that's the volume right there. You need to pre-train it on a very large corpus of data, and then the fine-tuning can be done like on a smaller, much smaller data set.
understood. Okay, so did you have a particular set of pre-existing technologies that you based this assistant on?
So we were looking a lot at what the competition is doing. Obviously, you need to have like a healthy status report of what's happening, and the best thing that's out there right now, but obviously not in all the languages of the world, is Dialogflow from Google. So I'm not ashamed to say this. That's the best product, and we try to guide our implementation to at least match that product. Obviously, that product, as I said, is not present in all the languages, and they don't offer you any type of support for the state machine or the graph part of the whole product. So what they do offer is basically just a understanding module for English and Chinese. So yeah, that was the most influential technology that we looked at.
Okay, but if Google comes up with such a product and they have accurate speech recognition engines and of course very powerful natural language generation uh, engines, should anyone assume that this project is just an interface built on top of Google's product?
So that question kind of has two or three parts to it. So first of all, the natural language generation itself is still an open research topic. And that is because if you ask the neural network to actually generate a response, For a very short response, it might make sense. It might do a good job of it. But for longer explanations or for very particular details that it needs to offer, it kind of wanders off and kind of produces contextually relevant results, but a little bit maybe out of industry scope. So, for example, you can make it write amazing stories about unicorns, and it will wander off and tell you an amazing story about a unicorn. But if you actually wanted to, uh, give you a resume on what the product of a bank is, you're not going to allow it to wander off. You cannot do that. So you cannot do natural language generation at this point. So I think that was one of the questions. The other question probably is if we implement anything that Google already has, and the answer is no. We did all the implementing of our product ourselves. We run our own neural network with our own customized outputs, with our own customized structure. So the intellectual property basically is ours right now, and uh, reading the documentation and what companies like Google put online, it seems to me that they don't really care about producing language models for all the languages in the world. They care about empowering other companies and other people like myself to do it for their own language. And I think that's a good way to look at it in an kind of an open source environment.
Have you seen examples of such, let's say, less frequently used languages implemented on top of Google's product so far, other than Romanian?
Well, again, we don't implement it on top of Google product, so it's our own
Sorry about that.
implementation.
Sorry about that. Okay.
Yeah,
My
no
bad.
worry, no worry. So it's our own implementation. It's not on top of a Google product. It's basically Google inspired, if you may, out of the research and the code that they put up. We wanted to make a product at least as good as theirs, so it's inspired by that. But it's our own thing. And yes, I've been in close contact with the first. We did the first Romanian language model, and while we were doing it, I was in contact with the guys who were doing the first German language model. And it was a pretty interesting conversations that I was having with those guys because they were basically bumping into the same problems and issues that I was having. And because technology is so new, I mean, these transformer models like Bert or Albert or Roberta, all of these technologies came up in 2019. So because they're so new, there were probably lots of research centers around the world trying to do the same thing at the same time. So I was lucky enough to be in contact with the German guys who were doing the German first language model, and we did the first Romanian one.
Right. So, because you mentioned Bert, Robert, and Alberta, just for anyone who's listening and might not know too much about it, would you care to just
Sure,
provide a
sorry,
brief
sorry about
description?
that. Yeah, yeah, yeah. So the underlying technology or neural network architecture is called the transformer, and that's the new thing, the new kid on the block that's really hot. I'm not going to go into the details about what that means. Somebody who's listening to this podcast can basically look it up on the net. But what a BERT is a bidirectional encoder representation for a transformer. So I know there's a lots of words over there, but it basically suggests that the flow of information inside of the neural network brain is bidirectional. And obviously, it uses a transformer which has attention models. This attention model idea is very important, and it was a kind of a stroke of genius that well, I wouldn't credit it to anybody in particular. I don't know who had first. There's versions of the attention models in the computer vision world also. What an attention model is basically the network doesn't give as much attention to all the words in the sentence. So
It
basically,
provides weight to each of them, right?
yeah, basically it weights some of the words in the sentence as being more important for your outcome or for your output than other words in the sentence. So, for example, if you say I don't know, um, I can come up with lots of examples in Romania, but not in English right now. um, the fact that you stand on top of a bench, for example, well, the on top bit is very important for the attention model to understand what it is that you are actually doing. And it's also very important to the word bench because you're standing on top of the bench. So it kind of that type of mechanism of attention has been really interesting.
Yeah,
And
yeah, and I think that there's something that even Google hasn't sorted out yet, which is the use of commas. Um, I'm sometimes writing emails on my phone through voice to speech, speech to text. Sorry, and it can never understand when I'm putting in a comma or when I'm putting in a period, let alone putting in a colon. They can never
yeah, that's
understand that.
pretty. Yeah, I guess that's a little bit understandable. In a sense, when you as a human are using a comma in a textual representation of what you're saying, you kind of want to emphasize some grammatical rule or some pause in a dramatic pause in your speech. But then when you actually speak and you expect the machine to write the text for you, um, the dramatic pauses that you make are going to be very different from one person to another. So it could have quite a hard time to understand your style of pausing and your style of accentuating or
Do you see this being solved anytime soon? The comma problem?
It probably will be. I don't think it's of importance to solve the coma problem right now. I think there's lots of other important kind of wrinkles to get out of the way. A little bit more than that. Um,
What would you be thinking of?
so I know there's research right now happening in the direction of an end-to-end model. Basically, the architecture that I was describing to you is comprised of about three or four neural networks. There's a neural network that does speech to text, and then when you have the text, you do the natural language understanding neural networks. So that's the second one, and then you have a formulated an output, a textual output, and you do out of the textual output, you do a spectrogram representation of what that text should look like in spectrogram form. And this is the third network. And the fourth network takes the spectrogram representation of your text and produces the audio. So there are four networks in these architectures that work hand in hand. I know for a fact that there's lots of research going into creating basically a single input output network that receives audio and outputs audio. And to me, that's fantastic. That's like a brain in itself. So it's not, it doesn't, it does the understanding, it does the audio filtering, it does the spectrogram, all that. It does it inside of one single neural network.
Right. So, coming back to the virtual assistant you've built, it also generates active questions and I don't know, active content. Does it?
So that's another. I mentioned earlier that the natural language generation is an open research topic, and one thing that's been happening quite a lot is that you basically give it the intent of the user, let's say the intent and the entities, and then you might also give it some type of metadata, something like the user is a little bit upset, or the user wants to kind of he has an urgent tone, or he's more interested into buying this, or the profile of the user. And if you give it also the metadata and you ask it to generate content, it will start generating responses that are very different if it talks to you or if it talks to me. So it will be very personalized, tailored responses. And I think that's another thing that's being researched and ongoing. It's going to happen in the near future.
Indeed.
Right now,
Sorry, please go ahead.
yeah, no, no, no. Right now, the way the network interacts, basically the platform or the architecture interacts with the user, is that for any given request, if for example you want to I don't know, you want to book a flight to Berlin, you want to go to New York, and you're gonna have to tell it, when you want to leave, where from, when you want to come back, how many passengers, do you want to fly business, do you want to fly economic, how much is your spending budget, do you want a taxi waiting for you at the airport, and all of those details. Some of them are they're must-haves, and some of them are can be like a default. Like by default, you're gonna use the economic class, let's say.
Okay.
So in a conversation with a network that wants to, for example, to make a reservation for you to fly to Berlin, the network or the system already knows it needs to complete all of those details. And if a newbie, somebody comes along, like somebody who doesn't really know much about traveling, and he says, "Look, robot, I want to go to New York." Um, the robot or the system, the assistant, is gonna start asking you questions in order for it to fulfill all the informations required to get you to New York. So it's gonna ask you, when do you want to leave? Uh, where are you leaving from? How many people are there? Do you want a taxi to wait for you when you arrive? So in that sense, it also asks questions and it kind of has a dialogue with you.
Right. This brings me to a couple of episodes of Star Trek I've watched some times ago, and I remember that always the computer voice in Star Trek, at least in the next generation series, it always sounded so robotic. So, for example, I would ask for a flight, and I would say, "Yeah, I want to leave between next Tuesday and next Friday," and then computer, please give me alternatives for these days. And then the computer in Star Trek would say, Tuesday, flight not available. Wednesday, flight not available. How do you avoid the robot sounding too robotic and being closer to the natural?
This is one of the amazing bits that I was, awestruck when I came across it. So I was used to lots of chatbots or robot assistants, for telecom companies and such, that would, have the robotic voice or ask you to press dial the number 5 to get to certain menu template. And I was pretty sick of that, and I thought that that's not a good way to have a conversation. It's definitely not a good way to entertain a relationship with your client.
Indeed,
So
indeed, indeed.
yeah, so we were looking at, how to transform the textual messages that the natural language understanding would eventually produce into vocal responses. And as I mentioned in the architecture, there is also a neural network that does the interpretation of the spectrogram kind of into audio. And what we did is what we found, audiobooks for stories, kids for basically stories for kids,
Uh-huh.
like I don't even popular folklore stories for kids in Romanian. And we found those stories, and there was this particular character that we found about 6 to 8 hours of audio from, and we also had the textual transcript from the audio. So that's quite a lot of audio, 8 hours of text, written in stories, and you could say, that's a lot to
Munch through.
a lot of data, yeah. But actually, the big products probably use 100 hours of audio, and we try to train our model or wavelength model on this audio, like 8 hours of stories for kids, and the result is impressive. It basically talks with the same intonation as it did within the stories. It also has a little bit of accent of a Moldovan accent because the
Right.
the speaker was a little bit Moldovan, so it kind of picked up on those inflections and tones of voice. And it's a more or less just a copy of the speaker we found audiobooks from, and you can get it to say anything. Um, it's pretty wild to think that, with 10 hours of audio from something like Morgan Freeman or 10 hours of audio from Trump, you could do a deep fake that could say anything with the voice of Trump or with the voice of Morgan Freeman. But that's basically the state of technology right now.
Right. So that means that the assistant on hand at hand right now is able to, let's say, adopt different voices if needed.
Yeah, so whenever I meet new potential customers or clients, I usually extend them the idea that their voice or the customer care voice that they have, that's very important to their personality and to their image, to their relationship, an image that the clients form in their heads about that company. So my recommendation for each and every one of these companies is that they hire an actor, somebody whose voice they consider to be sexy,
Yeah.
and then they record about 10 hours of audio in their particular context, tra- m- maybe travel or banking or whatever. Just make that actor talk 10 hours about that thing and give us the audio and the transcript, the textual transcript of what he's talking about, and they're going to have an agent with that actor's voice.
Indeed, because if I'm Vodafone and I buy this agent, I don't want it to sound like the same agent employed by Orange, right?
Definitely, you want it to have your own Vodafone voice. You want to give it a name. You actually want this agent to, in the future, like 5 to 10 years time, right from now, you'll be talking to somebody at Vodafone with a name and a personality and all those characteristics that a human actually has. It needs to be, you know, insightful and empathic and all that.
Yeah. And speaking of which, does the assistant learn from individual users, or is it, I don't know, um, supposed to start learning at one point from individual users as to their particular talking patterns or
So this is an area of
idiosyncrasies, if you will?
Yeah, yeah, I get it. This is an area of machine learning that I think, well, it's called a number of ways. Most people, like the big people in the industry, like Andrew Karpathy or some other people like that, they probably call it active learning. And what active learning means is that the neural network gets better and better when it basically interacts with its user. But there's a false conception of the fact that the network, the neural network or the system learns real time during the conversation it has with the user. That's not the case, or at least not right now. More or less, the case is that, for example, if the agent doesn't understand what the user is saying, if the user wants to talk to a travel agent and he tells the travel agent that he wants him to buy some groceries, the travel agent is going to say, I don't understand. Could you please, reformulate or tell it to me in another way? Maybe I can understand that way. And if it does that, then we can capture that event when the neural network did not understand what the user is saying. And then let's say once a month or once a week, depending on the client's, exigencies, we can retrain the model on the utterances that it did not understand. So we basically iteratively make it better. But it's not real time. The network doesn't learn by talking to you in real time. It learns by talking to me, the engineer, once a week.
Okay, understood. Well, maybe you could switch it to the grocery agent in case
Yeah,
that is the context.
yeah, definitely. So I envision lots of these kind of narrow knowledge agents. So you are gonna have an agent for your grocery list, an agent for your travel, an agent for your insurance, an agent for your telecom company, whatever. But at some point, these agents are probably going to converge.
Indeed.
And there's probably going to be some type of a meta agent that understands more and more context about the world around it. And that's the point when it's going to get a little bit scary. I'm expecting them to be therapeutic agents, and basically agents that talk to people that feel lonely at home. I think that,
The fortune teller agent.
yeah, yeah, maybe that the fortune tell the magic, all you're gonna have agents for all of this stuff. I can bet lots of money on that. Yeah.
Right. So I was thinking about the new technology released by Google not so long ago. Actually, it's quite fresh, and it's called Tensorflow.js, I believe.
Yeah.
And I was wondering how this could interfere with instant learning by any agent for any narrow
So
purpose.
I think the principles are pretty much the same. The JS is basically just the framework or platform you kind of want to do the deployment on. So it's basically, you want to deploy it in a JavaScript web-based interface, or you want to deploy it on mobile, or do you want to deploy it in the cloud.
Apparently,
It's
it
just
makes the
a
connections a lot faster with
it,
the
it
setup.
might, it might. I'm not very, I haven't worked with deployment on JS up until this point because none of my customers asked for that. But I would be, I don't think it handles speech type of neural networks because those require pretty powerful GPUs. So I don't think they can be done, in a GS kind of image locally container on your mobile phone. For example, my MacBook Pro, it runs the transformer architecture without a problem on the CPU. But if I want to talk to it, if I want to talk to the actual neural network, it doesn't do the processing on its GPU or CPU because it's too light. So it needs to go to the cloud.
I understand. So that means that for this assistant, you employed some other type of hardware for processing.
Yeah, so most of well, if it's text based, we've got something like 7 milliseconds of answer time on a CPU. So you would imagine that on a GPU, you can scale that really, really crazily. But when it comes to voice and audio type of synthesis, those can only be done right now without having lag in the response or all that on powerful GPUs in the cloud. So even if you interact with the Google Assistant, most times you kind of have to wait a second till it responds.
Right.
And I don't think that processing is done necessarily or entirely on the phone. Some of it, I'm pretty sure it's done in the cloud.
Okay. Now, as a last question I have, what are the next steps for the assistant? Where do you see it going? And I don't know. What are your plans?
So I can see there's lots of competition in 2020. I think that's healthy. I think it's a sign that the industry is headed into that direction. I think Cegeka still has the edge. We still managed to do it first in Romania, and we managed to do it well enough such that we get leads and customers. I think next steps, uh, well, generally, when it comes to the technology, I'm very much looking forward to natural language generation, automatic generation, not just understanding. And just, I'm looking to reduce costs for customer service providers for like 70 to 80%, and I promise, I guarantee I can do that. And people are going crazy. They're like, I'm spending millions of dollars a year on customer service
I think every
just to.
service company does.
Yes, yes. And then when I come along and I'm like, I can scratch off 70% of those dollars for like, only a portion of that money, and they cannot believe it. They're like, no, this cannot be done. This is too good to be true. And I'm telling them, because they usually have a bad experience with chatbots in the past that used to do pattern matching. And I'm
Yeah,
telling them,
we all know
this,
those. We all know
yeah,
those.
yeah. And I'm like, this is not the same technology. And when I demo it to them, most people, they don't actually believe that it's real. They want to demo it themselves, and then I let them play with the technology. Do it yourself, demo it yourself, and they're just blown away by how fast it responds and by the ambiguities that it manages to handle.
I think it's
So,
all about accuracy, right?
oh,
Speed
even
and accuracy,
speed
actually.
and accuracy, yes, but even if you talk to your wife, you might not fully understand everything that she's saying. so
That's not a
so
good
so
example. That's not a good
so no no
example.
no 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 no. So hear me out on this. So even when you have interpersonal communication, you and your wife or you and your kids, you're not going to fully understand what they want all the time. So so the accuracy in this situation is not particularly 100%. You can't say you understand your wife 100%. Nobody understands, their spouses or their husbands 100%. So I think more than plain accuracy, we should be looking at whether or not the agent actually does the job it's meant for. Does it guide the user through a process that leads the user to buy a ticket to go to Paris? Does it guide the user through a process that makes it easier for the user to understand why he paid a lot of money on his telecom bill? um, so even if it's not 100% accurate all the time, if it actually manages to guide you through it, I think that's success.
Indeed, and also with a voice assistant, you also have the barrier of not perceiving the body language, which apparently, by many
Yeah.
psychologists, makes up to, I don't know, 70-75%
Yeah,
of
so
the
so there's
message.
there's a lot of buzz in this area too. Samsung have come up with a product that's called Neon, and this is actually 2020, or it's December 2019 or January 2020. And I think right now we're on the 16th of January, so this is a product that came up like a week or two ago. And the Neon product from Samsung is basically an digital assistant, but it also has a visual representation, like a body. It also has a face and gestures and all that. But if you look at the demos that they made at CES this year, you're going to see that, due to the high complexity of generating language, generating body um, insights, like facial expressions, body expressions, all that, it's kind of laggy. So we kind of still don't have the compute power to power this thing on our tablet or on our mobile phone. It needs to be powered by large GPUs in order for it to work.
I've seen demos of Neon, and it was scary.
It's pretty scary, yeah.
I mean,
It's pretty
they
scary.
looked exactly like actual persons.
Yeah, they look pretty real, yeah. And, I mean, I've seen demos of fake deep fakes of politicians saying lots of things that they shouldn't be saying,
Okay.
and those demos are they're made by a couple of really smart guys and researchers for a big company. They want to do some kind of crazy act of rebellion in their own backyard, and I think it's amazing. It's amazing that we can do these types of things, and definitely it's scary.
Yeah. So, do you see any application of this assistant and the feedback that it gets from users towards behavior analysis of the users?
Definitely, but behavior analysis of the users also refers to the actions that users make or their history or background. So there's a lot of research in the area of profiling your user, understanding what your user's personality type is, understanding when your user is going to want to renew his contract, the client lifetime value side of things.
Yeah, based on
And
location, emotion.
yeah, yeah, and all that. And what an agent like this brings extra to the table is, I'd say, the sentiment analysis. So an agent like this can understand if you're, in a nervous or urgent moment, or if you're kind of funny, light, relaxed, laid back about a subject, or if you're kind of undecided, then maybe it can tilt the balance.
So, thank you so much again, Andy, and best of luck going forward with this pretty interesting project, which is a first on the Romanian market and for the Romanian language, not only for the Romanian market, because we have about, I don't know, 4 million people living abroad. So it might get a bit of traction abroad as well. And I do hope that this will evolve into much more.
Thank you very much for having me again. It's been a pleasure, and I'm pretty confident we don't need luck. We're gonna knock it out of the ballpark.
Right on. Thanks a lot. This is Mihai Daniel Popa from Cegeka, Romania, signing out. All the best.